Hello students, in this session we are going to discuss about the binary addition, subtraction, multiplication and division. So let's start the session. First is the binary addition. This is nothing but the rules of the binary addition or the cases of the binary addition. A and B are two variables which will going to perform the additions. Then sum is the addition and next one is the carry. So in first case, if 0 and 0, A is equal to 0 and B is equal to 0 are add together, then sum is 0 and carry is 0. In second case, A is equal to 0 and B is equal to 1, that is 0 plus 1. In this case, sum is 1 and carry is 0, that is carry cannot be produced. Then in case number 3, A is equals to 1 and B is equals to 0, that is 1 plus 0. Sum is 1 and carry is 0. Then in last case, if A is equals to 1 and B is also equals to 1, then A plus 1 plus 1 is equals to 2. But in digital system, we cannot represent the 2 or we cannot take the 2. In digital system, we use only 0 and 1. So in 2 is the binary, 2 is the decimal number. The binary form of 2 is 1 0. That is sum is 0 and carry is 1. So this is nothing but the binary addition rules. Binary addition is the key for binary multiplication, subtraction and division. Then next rules are the binary subtraction rules. In this also there are 4 rules. A and B are the variables. And this is nothing but the subtraction, that is difference. And this one is the borrow. So in case number 1, if A is equals to 0 and B is equals to 0, then 0 minus 0 is equals to 0. That is the difference is 0. We cannot take the borrow. So borrow is equals to 0. So in case number 2, A is equals to 0 and B is equals to 1. That is 0 minus 1. So in this case, we can take one borrow. If we can take one borrow, so 1 and 0, the 1 0 is the binary number and the decimal number of 1 0 is 2. That is 2 minus 1 is equals to 1. That is difference is 1 and borrow also 1. So in case number 3, A is equals to 1 and B is equals to 0. 1 minus 0 is equals to 1. That is difference is 1. We cannot take the borrow. So borrow is equals to 0. In case number 4, A is equals to 1 and B is also equals to 1. That is a 1 minus 1 is equals to 0. Difference is 0 and borrow is 0. So this is the binary addition rules and this is the binary subtraction rule. These are some examples of the binary addition and binary subtraction. These examples we will going to learn in the next section. Further, we move towards the binary multiplication rule and binary division rule. So in binary multiplication rules, A and B are the variables and output means multiplication. So in case number 1, if A is equals to 0 and B is equals to 0, that is 0 multiplied with 0, then output is 0. In case number 2, A is equals to 0 and B is equals to 1, that is 0 multiplied with 1 is equals to 0, that is output is 0. In case number 3, A is equals to 1, B is equals to 0, that is 1 into 0 is equals to 0. In the last case, 1 is A is equals to 1 and B is also equals to 1. That is 1 into 1 is equals to 1. So in about 3 cases, if A is equals to 0 or if B is equals to 0, in that case output comes to 0. So this is the rules of the binary multiplication. Then binary division rules. If A is equals to 0 and B is equals to 1, then output is 0. And if A is equals to 1, B is equals to 1, then output is 1. That is, division by 0 is meaning the less. These are some examples of the binary multiplication and binary division. The next part of this session is 1's complement of binary number and 2's complement of binary number. So first we talk about the 1's complement of binary number. The 1's complement of the binary number, that is the inversion of each bit. If we this is called as a complement rule. This complement value represents the negative of the original value. That is, 1's complement system is very easy to implement merely using the inverters. The 1's complement of binary number is obtained by changing 0 to 1 and 1 to 0. That is inversion of bit. Both the numbers complement each other. If one of these number is positive, the other will be negative, with the same magnitude and vice versa. This is nothing but the 1's complement of the binary number. And 2's complement of binary number, that means if 1 is added to the 1's complement of number, then it will obtain the 2's complement of the number. If we have the 1 binary number, then take its 1's complement, that is inversion of each bit, and then LSB of this 1's complement number, add 1 to the LSB and obtain the 2's complement of this binary number. The next part is the subtraction using 1's complement. These are the rules of the subtraction using 1's complement. Subtraction of smaller number from a larger number. That is step number 1, calculate the 1's complement of smaller number. In step number 2, add the 1's complement to the larger number. In step number 3, if carry comes in the MSB, remove the carry and add it to the result. For example, if we have A minus B, that is B is the small number and A is the large number, then take B, take 1's complement of the B, then add A to the 1's complement of the B, and if the carry comes, that is if the carry is 1, then add this carry to the result, and final answer should be your result. Then subtraction using 1's complement, that is larger number from a smaller number. Then calculate 1's complement of larger number, add 1's complement in a smaller number. The result will be in 1's complement form, that is negative form. Calculate 1's complement of final value of the assigned negative sign to the result. These are the subtraction using 1's complement method. Then advantages of using 1's complement subtraction. First advantage is this can be easily obtained by simply inverting each bit in the numbers. And second advantage is this subtraction can be done with a binary adder, thus it is useful in a arithmetic logic circuit. Then we will see about the subtraction using second complement. These are the steps of subtraction using second complement with the smaller number from a larger number. Subtraction of smaller number from a larger number. Step number 1 is calculate the second complement of smaller number, then add the 2's complement of the larger to the larger number. If carry comes in the MSB, then discard the carry. That is, our answer is positive form. Then subtraction using larger number from a smaller number. And step number 1 is the calculate 2's complement of larger number. Then add 2's complement in a smaller number and the result will be 2's complement form. That is, calculate 2's complement of final value and assign negative sign to that result. So this is the subtraction using 2's complement method. Then further topic is unsigned and signed numbers. Numbers, unsigned numbers, that is numbers without any positive and negative sign, represents only magnitude, that is unsigned number. And signed magnitude numbers are as follows. In binary system, both positive and negative values are possible. In this, we use zeros and ones to represent every number. The representation of number is known as a signed number. That is, 0 indicates positive number and 1 indicates negative number. For example, plus 7 is equals to 0, 1, 1, 1 and minus 7 is equals to 1, 1, 1, 1. This kind of representation for a signed numbers is called as a signed magnitude representation. So different methods for representation of binary signed numbers are the signed magnitude form, 1's complement form and 2's complement form. So this is all about the binary arithmetic operations in a digital system.